If the human Sikh gurus are part of God, ocean, which according to Sikh mythology makes Sikh gurus God, then God is imperfect because gurus, humans, are imperfect.
From a Sikh perspective, this question doesn't really arise. The Sikh definition of what Guru Nanak Dev Ji was is a fully realized being, at one with the Creator and also able to enlighten us. The concept might be like, take the ocean and take a cup out of the ocean and put it to this side. For us, that's Guru Nanak. He's the cup and there's the ocean. But what's the difference? It's still water. Yes, the ocean is massive and it's got loads and loads of water inside it, but the cup is still water from the ocean. So from one angle, Guru Nanak Dev Ji is not waheguru, but from the other angle, he's the same thing. Also, if from a textual point of view, Gurbani is very clear about this. We also have the Svaiye of the Pat. These are the poets that were in and around Guruji's time, in Guru Arjan Dev Ji's time, and they talk about Guru Nanak and they say how great he was and how he was one with the Creator. And
but when you look at how the mechanisms of the body work, it's almost automatic to talk about them being designed, but really gives the proof is when you look at how badly designed they are. No sensible person would have ever left the body the way it is.
Like what? What's a good example of that?
Name your part of the body that you want to. Probably a lot of people watching this show have been on a skateboard. And for instance, they fall like this and they break these bones here. The doctors call it a Colles fracture. If you look on the skeleton, it's these two bones fracture right there. Now people have been falling down like that for, you know, a million years, or our predecessors have. Why didn't natural selection make these bones thicker? And the answer is this. We can do this marvelous thing of rotating our arms all the way around like that. I won't do it for this model because it's a Victorian skeleton that's quite delicate. But notice how those bones go across each other. If those bones were thicker, it would be more like this. And then you couldn't throw. So it's a trade-off, isn't it? Now this is something that any machine would be limited by. But when they make robots, they still are not using two different firm rods usually. There's usually one that rotates.
Okay, so it's kind of historical legacy then.
That's the other part of it. Yes, exactly. Historical legacy. The technical term is path dependence. It's all the same. Probably a lot of viewers have a keyboard for their computer. In fact, we all have what's called a QWERTY keyboard. And that keyboard was designed specifically to keep typewriter keys from sticking. And so they put all the vowels a fair way away from each other, so there's a little delay. Well, this means we all type slowly because our keyboards are designed to make us type slowly.
There are better designs of keyboards.
There are. What's it called? The Dvorak.
Yes, and once you've learned how to do it, you go faster, don't you?
You first. I would, if the time it takes to learn.
Exactly. I'll never do that.
I think the world may be stuck with these mal-designed keyboards for another 100 years just because they started off that way and the cost of changing is too high for all of us, so we're stuck with it. Likewise, there are all kinds of aspects of the body that might be done differently, but we've gone down one particular path and can't get out of it.
I mean, the example I like to use with machines is, imagine if you had to evolve the jet engine from the propeller engine by changing it one little step at a time.
Not possible.
Or if you did, you have a pretty lousy jet engine.
Exactly so. Everything in the body, once you take an evolutionary view, is trade-offs all the way down.
So you're kind of answering the question of why the body goes wrong, and there are all sorts of reasons why it goes wrong. What other aspects are there of Darwinian medicine that doctors ought to know
I should emphasize that this field really got going by a collaboration of mine with George Williams. Viewers may or may not know he's one of the more famous and worthy evolutionary biologists of our time. He taught us. Right. And it's very closely related to your work on selfish genes, of course, because prior to Williams's work in 1966, most people thought that natural selection shaped species for their own good. And now we know that selection works much more strongly at the level of the gene. So that theme has infused a lot of my work with George Williams. But as we started talking in our collaboration about why the body isn't better designed, we finally narrowed it down to 6 possible reasons. I'm using the word design over and over again.
Go ahead.
I can see why other people do, you know?
Yes.
It's very hard to find another word to refer to these mechanisms that work so well.
I mean, once and for all, it looks like design. Natural
like
selection produces a powerful illusion of design.
They work.
You've just been telling us some reasons why it's actually not entirely a good analogy, because there are imperfections which no human designer would tolerate.
Right. And maybe we should pause at this moment to ask if the body is a machine. I always thought certainly that the body is a machine.
I always used to say it was a machine.
Yes, but that's a metaphor which is fundamentally wrong. The body is not a machine. It works very well. It has levers and pulleys and connections and all the rest. But a machine has blueprints, one master design, and a manufacturing process that moves from the blueprint to the finished version, which is all the same. There are no blueprints for the body. There's a genome that has information in it, but some people imagine that that there is a normal genome. There is no normal genome. There are only genes. And those genes that make bodies that end up reproducing more than others, they go on and become more frequent in the future. Other genes become less frequent and are gone. The genome is a collection of genes that work. It's nothing like a blueprint.
No, it's certainly nothing like a blueprint. I still think that in some respects it's reasonable to talk about the body as a machine. In other respects it's not. I mean, it's not designed, it doesn't have a blueprint. On the other hand, there's a mechanism which, I mean, think, you know, a heart is a pump, an eye is an image-forming device with all sorts of respects in which it resembles a camera, with an iris diaphragm that narrows down and so on. Right. I mean, it's kind of a machine, but it's a different sort of machine, and above all, it has a different history.
Yeah, exactly so, and the other evidence that it's not a machine is that a machine can be changed completely by the designer deciding
to the drawing board.
Right, and as the example we just talked about with regards to the eye, natural selection can never go back and start fresh. It has to use what it has and make very, very tiny changes. And again, I'm talking about natural selection almost as if it has a mind. It's so easy to talk that way, isn't it? In fact, what we're dealing with are tiny, tiny changes in the eye or the bones, and individuals with bones that are too thick here aren't going to do as well as individuals who can rotate their wrist very nicely around that axis.
Compromises and historical legacies are one reason why we are not perfect, why we get ill. Right. But of course there are other genes in us, there are other creatures in us, there are bacteria, there are worms, and so the Darwinian has to look at them as well.
Indeed, and I am amazed, Richard, that what we call metazoans, multi-celled organisms, have actually been able to evolve. And the reason is that bacteria and viruses replicate so quickly, a few hours sometimes they can reproduce themselves, that they can evolve very, very quickly. And we're stuck with 20 years at least, or around between generations. How is it that we can resist infection when they can evolve so quickly to find ways around our defenses? We're getting answers to this question. There are things called innate defenses that are in most organisms that protect us, but this is one of the huge transitions in the process of the origins of life.
Well, above all, we have an immune system, don't we, which kind of does a sort of Darwinian job.
But exactly what that transition was between one-celled or few-celled organisms and multi-celled organisms, the ability of an immune system that can protect us from other things that evolve so much faster than we do, that want to have us for lunch, must be very crucial in the origins of life.
But isn't it right that the immune system actually is a selective, I mean, there is a kind of selection going on in the immune system
it's a version
within your own body?
It's a version of selection. It's not exactly like natural selection because it's very carefully orchestrated. I mean, certain cells that are making the kinds of antibodies that kill the particular bacteria that's in you this time, those cells reproduce themselves more and make more antibody, and they even remember. So that if you've had measles once, you probably won't get it a second time because the immune system has this memory. It's not exactly the same as...
Now, when you say the immune system has a memory, that again is a selective process. I mean, it's
that's right.
The ones that have the...
Individuals who don't have that memory don't do very well.
Yes.
On the negative side of things, however, there's another process within the body that's very much like natural selection. And we should emphasize that this principle of selection is one where there's all kinds of variation, and certain individuals in that population go forward. You know, the best way of talking about it, what I like to say is to think about the jar of coins that you have, where you empty your pockets every night. And every night you reach into your pocket and you take out the coins and you throw them in that jar. It's a random selection of coins that goes into the jar, but in the morning you reach in and take out coins, but you don't take out a random sample. You take out the silver ones, the ones that are worth something. What happens over weeks and months? That jar changes from a mixture of all kinds of coins to one that's almost all pennies. And once it's all looking coppery, it's hardly worth digging anymore in there. Now this is an example of a selection process, not natural selection, but selection nonetheless, that explains how it's changed from a mixture to a pure copper kind of jar.